Now let's talk reflection in the x-axis. If we're reflecting a graph in the x-axis, we change the signs of the y-coordinate this time, and the x-coordinates stay the same. So here in our graph, we have the point 1, 2. If I'm reflecting across the x-axis, its reflection is 1, -2. The y-coordinate changes sign, but the x-coordinate remains the same. So one way to remember this, the difference between reflection in the x-axis and reflection in the y-axis, for the axis that you're reflecting over, that coordinate does not change. The other coordinate changes. So reflection in the x-coordinate stays the same, y-coordinate changes sign. If we're reflecting in y, the y-coordinates stay the same and the x-coordinates change sign. So now we're going to repeat the same exercises we did for reflecting in the y-axis. This time we're going to reflect in the x-axis and see how that changes the different graphs, how the reflections look different. So doing the first one together, I'll do 2 points just like before, and then I want you to do the other 2 on your own. I'll take this point here first and this point here second, and then I'll have you do the other 2. So starting out with the blue point, we have the ordered pair 4, 1. If we're reflecting across the x-axis this time, we're going across the x-axis, we get our new ordered pair. Our new point is 4, -1, reflected across the x-axis this time. Similarly for our point -2, -1, reflecting across the x-axis means I'm at -2, +1. X-coordinate stays the same, the y-coordinate changes sign. Pause the video and try these last 2 on your own. And now check it out. This time, instead of looking at the y-axis as the reflection, we're looking at the x-axis as the reflection. So now, if we take this graph and we fold it in half on the x-axis, these points will line up. And that's what it means to reflect across the x-axis. Repeating the same procedure we do, pause, try this one out on your own, and when you resume, I'll have the solution. And here we have our reflection across the x-axis. Reflecting our end points of these line segments across that x-axis, and then we connect them in the same way that they were connected before. So notice that the blue ordered pair and the green ordered pair are not connected in the original, so they're not going to be connected in our reflection. Looking at reflecting a shape, pause, try it on your own, see if you got the right answer. And here we have our reflection of that shape across that x-axis. Our ordered pairs 4, 0, and 0, 0 don't change because they're on the x-axis. The only point that we had to really worry about was the point 6, 4 to make sure that it was reflected below, and then connecting it appropriately. And now let's talk about our function. Same idea, reflect that function across the x-axis. Pause, try it on your own, resume. And there we have our reflection. Pointing out the ordered pairs, 3, 4 here up top right becomes 3, -4 in the reflection. The y-coordinate changes, the x-coordinate stays the same. In the next part of this lesson, we're going to flip it around. Instead of given an image and drawing its reflection, you're given the image and its reflection, and you're being asked what type of reflection it is. So I want you to take a look at these and try these on your own. You can always check your answers in the OneNote. The idea here is being able to identify what type of reflection is being done. So here we have solid line segments. The solid graph is the original, and the dashed graph is our reflection. So if I take 1 point on this graph, let's say this far right one, this is at 3, 2, I look at its reflection, which seems to be this one right here, and its reflection is at 3, -2. I also notice the other reflections that happen. I'm going to color them with different colors so that we can identify them a little bit easier. Because in this graph, my y-coordinate changes and my x-coordinate stays the same, this is a reflection in the x-axis. We can also look at if we fold our paper along the x-axis. If we fold our paper along the x-axis, these two images would line up. How about this one in number 2? If you guessed a y-axis reflection, you're correct. The y-coordinate stays the same, and the x-coordinate changes sign. This last one is more for fun than anything else. I will tell you I'm not going to test you on a double reflection in our class, but it is good to notice that if I have this point here, which is 3, 2, and I have a corresponding point at -3, -2, both of the signs change. So instead of just being a single reflection across one axis, this one has been reflected across the x and the y. We call this a double reflection. So if I were to fold my paper once along one axis and then once again along the other axis, then our two graphs will line up. So this is a double reflection because both coordinates change signs. Sometimes this is also called a reflection across the origin because we're reflecting across both axes. But again, I'm not going to test you on a double reflection. Know how to manage the single axis reflections.